In this video, we're going to start exploring solving rational equations. Again, a rational expression was one where we said we have a fraction involving polynomials, p of x over q of x, and we got to make sure, again, q of x doesn't equal 0 because you cannot divide by 0. Okay, we're going to look at one method of solving rational equations involving making denominators equal, because we're coming back to this idea. We have a proportion, and a proportion means I have an equation that's basically a fraction equals a fraction. If we have this, two fractions have to be equal, then we can say if the denominators are equal, the numerators must also be equal, and we can take advantage of that to help us solve that. So for example, if I had 3 over 10 equals x over 10, I can say here, since I have on these fractions, I have 10 equals 10, then in order for 3 over 10 is something over 10, x has to equal 3. And I can take advantage of that to help make solving these a lot easier. Now, if I have a problem like 4 over 7 equals x over 3, my denominators aren't equal. But I can make common denominators. I can make my denominators equal. So we say my common denominator is going to have a factor of 7 and a factor of 3. So I'll take this one times 3 over 3, and this one times 7 over 7. Again, we have to multiply top and bottom by the same thing because 7 over 7 is 1. 3 over 3 is 1. I really multiply both sides of the equation by the same number, and that's 1, so it doesn't change anything. But it changes the way it looks. And I get 12 over 21 equals 7 over 21. And so, since, let's fix that, 7x over 21. And since the denominators are equal, I can say the numerators have to be equal. 12 has to equal 7x, so x has to equal 12 over 7. That's our big idea. And we're just going to explore some of the ramifications, what happens when we start messing with some of these rational functions and do this. So again, our big idea, this whole thing, if we can get it to be a fraction equals a fraction and make the denominators equal, then the numerators have to be equal. So if I were to come along with 3 over x plus 1 equals 2x over x plus 1, I could come back to my same thing and say, oh, look, denominators are equal, so the numerators have to be equal. 3 equals 2x, so x equals 3 halves, or 1.5. Now here's where we have to start being careful. 5x over x minus 2 equals 10 over x minus 2. Again, this looks nice and easy. X minus 2 equals x minus 2. So 5x has to equal 10. So x equals 2. Sounds great. However, we look at our denominators. X minus 2, I can't have the denominator equal to 0. So if x minus 2 equals 0, x is 2. And I can't have x equal to 2. That's the no-no. That is super bad. That's where our vertical asymptotes came. It went to infinity because we can't divide by 0. So my solution says x equals 2 will make this true, but I can't make x equals true, so this one has no solution. And this is what's called an extraneous solution. Gotta be careful. It's the wrong solution, not because, oh, I plug into 2 and this doesn't make this true. It's because that makes the denominator 0 and I can't do that. So that's an extra solution that comes out of this idea of, hey, I'm ignoring the denominator, just working with the numerators, but I gotta keep in mind I can't make my denominator 0. So that's one thing we have to be careful of. So these are the nice problems. The denominators are already equal. But what if they're not? That's where the fun begins. So we'll look at this problem. 3 over x plus 2 equals 6 over x minus 1. Now here my denominators are not equal, so I need to make them equal. That's kind of like we did up here with the numbers. 7 did not equal 3, so we said, what's the common denominator? And often an easy way to get a common denominator is just multiply the two denominators together. So what happens if we do here? We say if I make my common denominator x minus 1 times x plus 2, x minus 1 times x plus 2. Again, I can't just change the denominator. I need to multiply top and bottom by the same number so that I don't change the equation. So I end up here and get 3 times x is 3x. 3 times minus 1 is a minus 3. I'm not going to actually multiply the denominators together, because when solving, I'm going to ignore the denominators. And with them in factored form, I can easily see where my zeros are. Where are the values that will cause extraneous solutions? That's going to be 1 and negative 2. If I multiply that out, then it's harder to just see that. So I may as well just leave it. 6 times x is 6x. 6 times 2 is 12. And again, my denominators are equal, so I can just look at the numerators. So I would say 3x minus 3 equals 6x plus 12. And I need to solve this. So get no like terms on the same side. Now I can put x on either side. A lot of times we like to say x equals, but I always look which is smaller. 3 is smaller than 6, so we'll move that one over. We get negative 3 equals 3x plus 12. So since I put the x's here, I'll move this constant over to the other side. It's positive, so I subtract it. Negative 15 equals 3x. Divide by 3. And I get x equals a negative 5. I check it against my asymptotes. What can x not be? Well, x can't be negative, or x can't be positive 1. Negative, positive. That's so easy to do. X cannot be 1 or negative 2. Well, it's not. So my negative 5 looks good. I erased too far. The other thing to just do is plug that in. If I plug into here, I can say 3 over 5 plus 2 equals 6 over 5 minus 1. Oh, that's a negative 5. There we go. So negative 5 plus 2 is a negative 3. 3 over a negative 3. Negative 5 minus 1 is negative 6. I get negative 1 equals a negative 1, and that checks. So that is always a good idea. Plug it back in and check. But first thing you look for is say, hey, is it one of these asymptotes? Is it something that's going to give me problems? Now, let's come over here. What are some other things that can mess me up? Let's look at this one. 8x minus 8 over x squared minus 4 equals 4 over x minus 2. Go through and let's do exactly what we just did. X minus 2, x minus 2, x squared minus 4, x squared minus 4. So here, I got to FOIL that one out. So I'm going to get 8x squared minus 8x minus 16x plus 16. This is all over my x minus 2, x squared minus 4. Over here I have 4x squared minus 16 over my x minus 2, x squared minus 4. So again, I got my denominators are the same, so I'll set my numerators equal. 8x squared, I'll say minus 8 minus 16 is going to be minus 24 plus 16. 4x squared minus 16. Again, I'll do the same trick. I look at my leading term, 8, 4. That's the smaller, so we're going to move that over. And I'm also going to move this 16 over. Because we're dealing with a quadratic. 4x squared minus 24x plus 32 equals 0. And, well, these are all multiples of 4. So let's just divide both sides by 4. X squared minus 6x plus 8 equals 0. Now, to solve this, I'm going to look at, well, let's try the quadratic formula. Well, no, let's try to see if it factors. Factoring would be nice. Does it factor? If we have x squared here, we need x and x. We have 8 down here. This is negative, so these are both going to be negative numbers. To negative times a negative be positive, so we're going to take a negative 4 and a negative 2. Negative 2 times 4 is positive 8, and negative 2x plus a negative 4x is giving me my negative 6x. So that works. X minus 4, x minus 2 equals 0. So now we just say, oh, we're looking for zeros of a polynomial, x equals 4 or x equals 2. But look up here. X cannot equal 2. So this one is out, and x equals 4 is my solution. That's starting to be a little bit of work here, right? Let's look at this problem in another light. 8x minus 8 over x squared minus 4 equals 4 over x minus 2. I have this quadratic here, x squared minus 4. What if I try to factor that? X and X. I need a positive and a negative. If I go 2 and negative 2, I get 2x plus 2x is going to be 0. I have no x term. I got my negative 4. This is actually x minus 8 over x minus 2 times x plus 2. Now when I look to find my common denominator, I have an x minus 2 on both sides. I just need to have an x plus 2 over here. So I could have just, instead of multiplying both equations and getting a huge denominator, I could just leave this one alone and multiply that one. And I get 8x minus 8 over x minus 2, x plus 2 equals 4x plus 8 over x minus 2, x plus 2. So now denominators are equal. We say 8x minus 8 equals 4x plus 8. So again, we'll take things over to the other side. Out of the way. Subtract my 4x. Subtract 8. Actually, let's not do that one. Because I don't have a quadratic, I don't need to get everything on the other side. So let's move this over to that side. Add 8 to both sides. So here I'm going to get 4x. Here I'm going to get equals 16. And I come down and I get my x equals 4. Which is the same answer as I got over here. And this was a lot easier to do. I didn't have to FOIL out. I didn't have to deal with a quadratic equation. I didn't have to try to factor that quadratic equation, although I did have to factor to find this common denominator. But this will help you if you can do it. Look for opportunities to factor that denominator out and see, can I make the lowest common denominator? With numbers, don't get the lowest common denominator. That's okay. Big numbers, I can do that with a fraction. But here, we ended up with a linear equation to solve versus a quadratic equation to solve. And this one is so much easier to do. The other thing I just kind of want to point out is, let's do this. That whole idea of the extraneous solution. If we look at this, we said x equals 2 is one of my possible solutions. Well, if we look at what we did, we multiplied by x minus 2 on both sides. If I said x equals 2, when I multiply, I take 2 minus 2, what does that equal? 0. I'm multiplying this side times 0. And 2 squared minus 4 also equals 0. So when I went through and multiplied by this, with that solution of 2, I really said, well, if I multiply both sides by 0, I get 0 equals 0, and duh, that's true. So this is where this extraneous solution popped up. They don't always pop up that way. But if we don't multiply by a common denominator, and we double up a factor, sometimes we'll do that. So that's something to watch out, to be careful of. So hopefully this will help you out some. Have a great day.